Alright, this is the parts you're going to need. Hayes slider hat, you get the spacer, you get the springs, you also get those washers, you get an inner basket, and you get these springs for weight. They adjust how fast the arms contract and clamp down. These springs are for your stall speed. You stick them underneath that hat, and the tighter you get, the higher the stall speed. And there you get a basket that's welded on the inside, inner basket. That spacer, these Allen head bolts to now put on the extended spacer. Alright, that's the parts you're gonna get in your kit. Alright, I've had this installed in the bike a couple of times. Here's the inner basket. There's all the bearings and kit shims and stuff that go in it from the factory. I'll show you what you need to reuse, what has to be in it exactly, because I've done it a couple times. This washer, this basket goes in first. Your new basket from Hayes. Then the inner bearing, race for the bearing. Then I put the OEM Kawasaki bearing back in. And just wiggle it around. I'm doing this because I put this in the bike 3 or 4 times, talked to a bunch of people, and I never can seem to get it right. But now that I'm starting to get it dialed in, I want to help you get your slider dialed in. It took me a very long time. All right, you're going to need this, I think it's called thrust bearing washer and spacer. This is going to need shims behind it or forward. This is what they're talking about when you adjust your air gap in the bike. Well, not air gap. You adjust the shim thickness of the inner basket. And I'm just showing you, my inner basket would move around about 40 thousandths. These washers take care of that 40 thousandths. At the end of the video, I'll show you what to look for to decide how many you need. Now you can put the bearings on either side of this. They should actually have a bearing on either side of it. So that's what I'm gonna do. But you're gonna have to play with this to get your tolerances right. So I'm just putting it in to show you now, and then at the end, after you get it all in like you will on your bike, I'll tell you how to measure these things, because I had a little bit of problem with how to measure the air gap on this bike, since you can't get feeler gauges in, and how to measure this right here. And this is the main problem I was having with my bike. All right, so next, this washer goes on your inner basket. Make sure those washers don't fall off. And your clutch pack. You want to have your clutch pack set to factory OEM specs, which is X amount of millimeters. I think this one's a 1.9 or 1 or maybe 2.0 inches. So just see what yours is. You can go from there. Now you want to put the nut on to hold the inner basket in place. Like I'm saying, I'm just showing you how it goes together. After you put it together, you're going to have to take it back apart, because you're going to measure 2 tolerances. If you have these tolerances wrong, your slider won't slide. It'll do all kind of weird things, and I've been figuring that out over the time. All right, so you want to put your clutches in fiber first, then steel, and you want the rounded part to go towards the inside. Now you're going to want to do this over and over again until you get to the last one. Make sure the flat piece goes to the back, the bevel piece goes to the inside. Now how you're going to adjust the height of these clutches is Some of them are going to be thicker than the other ones. Some of the steels are going to be thicker. So you want to order some thinner or thicker steels. Usually the thickest steels I have are measured with this gauge calculator. I'm showing you how to measure the stack height. Now you take the whole stack height, not what I put in the bike. Take what I put in the bike plus this. I'm just showing you how to. So you do that, and your overall measurement number would be the stack height for your bike. So then again, you want to have a certain number for that stack height. And then you measure your air gap, and then you change your stack height to take away from the air gap. So like I'm saying, just install these, and we'll go over how to adjust your air gap. It seems it was kind of hard for me to wrap my head around. It's taken me years to get this right, and people like Hayes will tell me something or something different, and the problem I end up having is not the problem that they ended up saying it was. So I want to show you the problem that I had, which was those thrust bearing washers, and maybe this will help you with the problems you're having. My clutch I have 6,500 stall springs in it, and it would kind of grab every now and again and start to walk away at the line, even with the air gap set completely right and the stack height where I need it. So after you get your last steel on, or your last fiber on, you want to put it there. Then you want to press in on this, and from the edge of the basket, you want to use the back of the micrometer, and it will give you a distance. You want to measure from the outer clutch basket or the inner clutch basket. Use a straight edge, or you can just measure from one or the other. The outer basket, not the inner basket. And measure the air gap between that piece of metal in the outer basket and the clutch. That right there, the distance from the outer basket to the clutch is your air gap. Once you measure this, you'll know how far your hat has to travel to touch your clutch. And the only way you can adjust this, if you want it to adjust, because you're supposed to have between, MTC uses about 50 thousandths of air gap. Hayes actually requires 100 thousandths of air gap for a slider. I didn't quite use 100. I think that's a little much. But you see how I'm just putting it on the edge and measuring down to the first clutch plate. And then it'll show you the number you have, which is if it's 40, 30, 100. Mine isn't that much. I actually had a lot less air gap, and I'll tell you why. See, I have 56 thousandths air gap, which is fine with 50. I think it ended up being 40. But if I want 100 thousandths, I have to take another, like say I have 50 and I want to get 100 thousandths of air gap, I have to take 50 thousandths out the clutch. So you do that by measuring your steels. Like, it depends on the thickness of your steels. All of them could be different sizes. So you read the thickness of your steels, and if you have like a 2.15 steel, you want to take, like, let's say 15 thousandths out of that. So you would try to look for a 2.0 steel to replace it with. And some of them, Kawasaki even has some 190s in the packs I get, so you can knock 25 thousandths right off of that. So all you would have to do is change two 2.15 steels to two 190s, and you would effectively make the gap up for the 50 thousandths. So now, instead of with your full stack how you had 50 thousandths before, you changed the two 1.5s to two 190s, just two of the steels, and it will now give you 100 thousandths worth of air gap because it is subtracting from your stack height. All right, so now I've got everything how I want it, how you want to get it to test fit it in your bike, and I'm impacting it down. You just hold the clutch. You can't over impact it because the clutch will slip. So it's fine. You can't torque it too much. So there we go. Now I'm going to pull some steels back out because I know I have 50 thousandths and I need 100 thousandths, like I was saying. So I'm going to show you how to measure the steels and figure out how big your steels are. See, I'm trying to get the number I was telling you. I have 50 and I need 100. But I'll tell you what else was my problem was. So I'm measuring the steels right now to see which ones are the thickest so I can get rid of effectively the thickest steels and get a lower air gap. So these are 1.15s. Those are the biggest Kawasaki ones I've seen. But they could be more, but this is the biggest one in my clutch pack. So look, I just used the dial caliper gauge to measure that. I use it to measure that. And the number I'm getting is 1.5. 1.15, sorry. I'm sorry the camera didn't show it. I didn't, it's bad cameraman angle. So these ones are thinner. You see how these ones are thinner? They come out to 90s. So these two ended up being thinner, and I subbed them for these two, which they actually didn't fit. I was just doing it to show you. So these are actually out of a Suzuki, but I did it to show you. I'm going to go back and fix the clutches when I order the ones I need. So after I got the clutches in, put the bike back together a week later or so, I stuck it all back together, and I'm trying to get the air gap I needed. So the hat actually sticks out a little bit, as you can see, and you have to measure that with your dial caliper gauge and subtract the amount. So that's actually 30 thousandths. I had 50 thousandths before, and that was taking up 30 thousandths of the gap. So there was actually 20 thousandths of air gap until the movement of the clutch, which gave me an overall air gap of 20 thousandths, which isn't what I wanted. It's actually too close. The hat's too close to the clutch and won't let it slip for very long. It'll engage really fast. So I did that, and that's what happened. So make sure you measure that. If your hat sticks out a little bit, make sure you measure that and subtract that from your air gap, because that will actually be taking up your air gap's space until your clutch meets. So I'm just putting everything back together, showing you how to get back together. And I'll go ahead and explain those washers I put behind the inner basket, the thrust. The problem I was having was my you can stack those washers I guess a little bit more, a little bit less. What you want to have is 0.08 thousandths to 0.15 thousandths of movement in your inner basket. I put one of those washers back there instead of 4. I had 30 thousandths to 40 thousandths worth of inner basket movement, and that is a lot of inner basket movement. And that was my problem. I would set the hat up. No, it was 30 thousandths. Set my clutch up to where I had 50 thousandths of air gap perfectly, and I didn't know my inner basket was moving 40 thousandths. And it was actually changing the air gap. So sometimes when it would walk out, when I was on the line revving the bike up, the clutch would move forward and actually start grabbing and chattering and walking the bike away. And then I would burn clutch packs up fast, because when the hat actually presses down, it wouldn't press the clutch down enough, because the inner basket would retract about 30 thousandths, and I would burn clutch packs out. So you want to make sure the inner basket is exactly how it needs to be. You only want 15 thousandths to 8 thousandths of movement in the inner basket. If you do not set that up, it doesn't matter if you get the air gap perfect. Nothing else in this equation matters. Your bike will do funny things. You'll burn clutch packs up even though you have tons of weight on your arms, and it'll just be a waste of time. And that's what I've found. I wasted a bunch of time trying to figure this thing out. So I'm just tightening the hat. Doesn't have to be very tight. These are very little bolts. They will break. So you don't want to have it very tight at all. You want it tightened evenly though. All right, also, let's talk about the significance of those washers and bolts on the end of those arms. So the significance of the washers and bolts, you can add more or add less. Once you have your air gap set, your clutch is going to engage at a certain distance. That's the amount of distance it takes for your hat to close the gap to get to the clutch pack under centrifugal force. So when your bike revs up, it'll close that gap by itself, right? All right, here's these springs. These springs you put in, there's lighter and heavy ones in the pack. The heavier it is, you turn it down, and it will actually pull the hat away and make it longer to take. It'll give you a higher stall speed, basically. And these are the washers I was talking about. I added more washers on. They'll increase the slip time. And if you want to, they'll decrease the slip time. If you want to increase the slip time, you take these springs and put it on the arms, and it'll take more centrifugal force to move the arms downwards. But you might want a lot of weight on them to lock the clutch up when it's fully engaged. Anyways, like I was saying, you put the weight on the arms. The more weight you have, the faster and harder the clutch will lock up. So if you have too long of a slide, you want to start adding weights to adjust your lockup speed. So the springs in the center adjust your stall speed. The heavier, the more clamped down, the more resistance it takes until your clutch locks down on the initial bite, which is your stall. The clutches on the arm, the nuts and bolts on the arms are the speed that the clutch locks up at. So they'll lock up faster the more weight and more harshly. And at the top end, they won't slip as much because they'll have more weight on it. So I have the heaviest springs in all the way down on the stall speed, which gives me about 6,500 stall speed in this bike. So my bike revs at 6,500 RPM. So before the bike takes off. Then the weight arms, I'm going to put some videos up showing you what different weights do to the bike to the different slides you want. You'll be able to hear it in the bike the longer the bike takes to move out without the clutch fully engaged. So you'll hear it go whomp compared to whomp. Like, I have no idea. I'll just show you with a video of me testing it out at the track. It usually takes about 15 or 20 times of me adjusting this at the track to get it right. So I'll put some videos up of every time I've adjusted it so you can actually listen to the bike and listen to kind of what you would want for your setup. And then again, those springs, the springs, I don't use them in my bike because I don't need my bike to slide longer. I actually want it to lock up faster. Those long springs with the hooks on the end of them will hook on each corner of those bolts you put on the end of those arms. And say you want your clutch to lock down heavy, you don't want it to slip on the big end or the other end because you have a lot of motor in your bike. So you want a lot of weight on those, but you need your bike to slide the clutch a little bit longer out the hole. You would add those springs. You would hook one to each arm, hook them to each other, and when the centrifugal force happens to lock the arms down, your bike would actually have to overcome that now spring tension, the 18 or 20 pounds of spring tension it's putting on. So it actually gives you more slide and you can have more weight at total lockup and more slide time. It's the only way you can adjust it if you're not adjusting all your slide time off of your weighted arms. So I hope that helps you. If you have any questions, ask me. I'm not an expert on this. I'm just trying to help people as much as I can. And thank you.
Everybody's flashing guns.